Imagine for a moment that an object traveling from the outskirts of the galaxy is sending us a coded message in one of nature's most enigmatic mathematical patterns. Picture yourself standing before a visitor from the depths of space, whose mere presence challenges our theories and whose light conceals an intelligible message. I have often been asked whether I have ever felt like an observer of something that transcends reason. The truth is yes. In fact, that feeling intensified when I heard about an interstellar comet crossing our solar system at an unimaginable speed. We named it 3I Atlas. Now, according to some, this celestial body does not merely dance to the rhythm of classical physics but emits pulses following the Fibonacci sequence, a language that seems to whisper to us, observe, prepare, understand. I could not help but feel a mix of awe and skepticism upon hearing this story. A comet that speaks? Science is sometimes so wondrous that it is mistaken for fiction. Yet the key to unraveling this mystery lies not in blind faith, but in analysis, understanding, and questioning every fact that reaches us. I remember well the excitement triggered by the announcement of the discovery of 3I Atlas. It was the first day of July in the year 2025 when the asteroid warning system, the very one that scans the sky for threats to Earth, detected an object moving too quickly. We immediately knew it was not following a closed orbit around the Sun. Its orbital calculations revealed a hyperbolic trajectory, indicating it had come from interstellar space. This was the third visitor of its kind recorded by humanity, following Oumuamua and Borisov. The sense of wonder enveloped us once more. A fragment from another solar system, perhaps from another era, presented itself to our instruments. In those initial hours, astronomers worldwide rushed to measure its brightness, speed, and orbit. The speed was staggering. It exceeded 130,000 kilometers per hour, faster than any comet we had previously studied. Its measurement suggested a nucleus several kilometers in diameter, perhaps 3 to 5, though its true size remained unknown due to the surrounding cloud of dust and gas. Despite its extreme characteristics, forecasts indicated no risk. Its closest point to our planet would be more than 260 million kilometers away, a distance allowing us to contemplate it without fear of collision. Nevertheless, its appearance awakened something beyond scientific fascination. Soon, we began to notice behaviors that did not align with the textbooks. The first oddities did not take long to emerge. One detail that particularly caught my attention was the so-called anti-tail or inverted tail. In cometary tradition, the tail always points away from the Sun due to solar wind pressure. Yet initial images of 3I Atlas showed a gas and dust outflow that appeared to head toward our star. At first, I thought it was a visual effect, a perspective illusion where dust particles ejected at different times crossed our line of sight and deceived us. It would not be the first time a comet toyed with our eyes. However, upon examining the spectra and temporal evolution, we discovered it was a real jet, composed of carbon dioxide and other gases, erupting from a specific region of the Sun-facing hemisphere. Inactive comets begin expelling jets as they approach solar heat, but this one did so at distances where ordinary comets still slumber. This suggested the presence of hypervolatile compounds, sublimating at extremely low temperatures. The preliminary conclusion was that its chemical composition differed from the comets familiar to us. This was reinforced when spectra of its gases revealed immense amounts of carbon dioxide and carbon monoxide, with only traces of water. The carbon dioxide to water ratio was overwhelming, as if it had emerged from a protoplanetary disk with a radically different chemistry from the one that birthed our system. As these peculiarities were confirmed, another astonishing coincidence fueled the mystery. The trajectory of 3I Atlas was almost perfectly aligned with the plane of the ecliptic, the imaginary band in which the planets orbit. When we traced its future path, we saw it would pass relatively close to Venus, then approach Mars, and finally brush Jupiter. This sequence recalled the gravitational assist maneuvers we employ for our probes, planning encounters with multiple bodies to gain speed or alter trajectory. Statistically, it is improbable for an interstellar object to have such an aligned path. Some scientists deemed it coincidence, but others began proposing hypotheses that sounded like movie scripts. They envisioned a controlled object using gas jets as thrusters to adjust speed and route for visiting several worlds in the system. Someone even dared to call the comet a galactic Trojan horse. As a physicist, I found the idea intriguing, though I knew it demanded extraordinary evidence. Nonetheless, the speculation was not baseless. When anomalies accumulate, the mind seeks patterns. As if that were not enough, the chemical composition continued to surprise. Observations from ground-based telescopes detected nickel vapors and a compound called nickel tetracarbonyl escaping from the comet millions of kilometers from the Sun. The presence of this compound drew chemists' attention, as we use it on Earth in industrial processes for metal purification. Its discovery in a comet raised legitimate questions. How could it form naturally in space? Moreover, no iron signals were detected in comparable proportions. Nickel was present, iron was not. When the James Webb Space Telescope analyzed the coma, it found carbon dioxide up to 8 times more abundant than water, confirming the notion of an unusual origin. The National Aeronautics and Space Administration, for its part, stated that the object posed no threat and was being monitored via the International Asteroid Warning Network. Internally, however, the agency activated defense protocols used for potentially hazardous objects. This quiet response spawned a stream of rumors. The agency publicly asserted no danger but bolstered its tracking system. Why such caution? The official explanation was that it served as good training, an opportunity to test international coordination ahead of a hypothetical real risk. Still, there was no shortage of those suspecting something more was being concealed. As perihelion approached, the comet's activity fluctuated unexpectedly. Photometric observations showed its light oscillating in a nearly periodic pattern, leading some to suggest it might have an elongated, cigar-like shape and be rotating. Others thought the variations could stem from internal cavities irregularly trapping and releasing gases. A team of astronomers even calculated that for its gas emissions not to noticeably deflect the trajectory, the nucleus must be extraordinarily massive, perhaps tens of billions of tons. An object of such mass could disregard gas expulsions that cause minor non-gravitational accelerations in ordinary comets. Yet this calculation, matching the observation of near-zero acceleration, posed another issue. Interstellar space is too sparse for such large objects to form via simple dust accumulation. Once again, the mind wrestled between logic and astonishment. All this led some circles to claim the National Aeronautics and Space Administration was silent because it knew something. Reality was more prosaic. The agency had run out of budget due to an administrative shutdown and curtailed website updates. The timing coincided with the comet's maximum approach to Mars, feeding the darkest interpretations. Truth, as usual, was less dramatic and more mundane. However, disinformation spreads faster than light, and many interpreted the silence as proof of a cover-up. It was in this scenario of accumulated enigmas that an even more startling claim emerged. Someone said 3I Atlas had emitted a signal coded in the Fibonacci sequence. According to the circulating story, radio telescopes had captured pulses following the series 8, 13, 8, 5, 13, 8, repeating with alarming precision. It was assured that the signal was recorded simultaneously at stations thousands of kilometers apart, ruling out instrumental errors. Furthermore, the pulse was said to be emitted at a frequency of 1,420 MHz, the so-called hydrogen line, often used in searches for extraterrestrial intelligence. To top it off, some claimed researchers had deciphered a message: observe, prepare, understand, the door awaits. I must admit that reading this narrative sent a shiver down my spine. The Fibonacci sequence is a numerical pattern where each number is the sum of the two preceding ones: 1, 1, 2, 3, 5, 8, 13, and so on. It possesses fascinating properties and appears in myriad natural phenomena, in the arrangement of plant leaves, snail shell spirals, galaxy shapes, and even human body proportions. It is linked to the golden ratio, a symbol of harmony and beauty. That a cosmic message would employ this pattern seems lifted from a science fiction novel. The frequency of 1,420 MHz corresponds to the hyperfine transition of the hydrogen atom, the emission line of the universe's most abundant element. It is the frequency radio astronomers proposed as a universal channel for interstellar messages, as any technological civilization would know it. The mere fact that the purported signal used this frequency was enough to ignite the imagination. Yet as a scientist, I have learned not to take headlines at face value. My first reaction was to verify the sources. Who made this detection? Where were the data? Had they been published in a journal or repository? I consulted colleagues in extraterrestrial intelligence searches and National Aeronautics and Space Administration staff. All replied with the same phrase: no confirmed signals. Social media erupted with a rumor no one in the scientific community endorsed. Some experts noted the story originated from a social network account known for spreading unsubstantiated astronomical curiosities. The rumor blended plausible details, like the hydrogen frequency reference, with unverified claims. Moreover, the supposed radio telescopes that captured the signal were unnamed. No scientific publication or recognized observatory reported such a discovery. The National Aeronautics and Space Administration reiterated that, to date, no artificial radio emissions from 3I Atlas had been detected. The extraterrestrial intelligence search community emphasized that it routinely monitors objects of interest and that a coherent signal would prompt an immediate announcement. After further inquiry, I learned some news portals debunked the story, labeling it false. This was the confirmation I needed. We faced a wave of disinformation. Nevertheless, the episode sparked engaging debates about the Fibonacci sequence, the hydrogen frequency, and what we would do if we received a cosmic message. The Fibonacci sequence is not merely a set of numbers appearing in flowers and snails. Mathematically, it converges to the golden ratio, the proportion between two segments such that the ratio of the larger to the whole equals the ratio of the whole to the smaller. This proportion, approximately 1.618, has been regarded for centuries as an expression of beauty and harmony. In biology, the series appears in phyllotaxis, the arrangement of leaves around a stem, enabling plants to maximize light capture. In astronomy, it has been argued to manifest in spiral galaxy distributions and density waves forming spiral arms. Some artists and architects have employed it in designing their works. In cryptography, easily recognizable mathematical series can serve as artificiality signals, standing out from background noise. In extraterrestrial life searches, many have proposed that a message encoded in universal mathematical patterns would be more likely recognized by an intelligent mind, regardless of biological origin. Prime numbers, pi, and of course the Fibonacci sequence form part of this pattern set. They are universal languages that could enable communication with beings not sharing our alphabet. Thus, when pulses following 8, 13, 8, 5, 13, 8 were mentioned, many thought it a way of saying, "We are here and we know mathematics." Reality, of course, seems not to support this hypothesis, but the thought experiment was enriching. The frequency of 1420 MHz is likewise no random number. It matches the frequency at which hydrogen atoms emit or absorb energy when their electrons change state. This process, known as hyperfine transition, produces a spectral line serving as a natural probe of the universe. In the 1950s, scientists like Cacconi and Morrison suggested that any civilization wishing to send signals would choose this frequency, as it stands out against cosmic background noise. Since then, many radio telescopes have monitored the hydrogen band for artificial signals. Our own history in searching for life beyond Earth is marked by moments like the famous WOW signal detected in 1977, an intense, brief emission near the hydrogen frequency. Though it never repeated and its origin remains a mystery, it sparked global interest. Hence, linking 3I Atlas's hypothetical signal to this frequency inevitably evoked memories of that event, as if past stories blended with present aspirations. The Fibonacci hydrogen channel combination was irresistible to the collective imagination. But even if no such signal existed, could an object like 3I Atlas emit radio pulses naturally? Phenomena generate periodic emissions. Pulsars, for instance, are rotating neutron stars emitting regular radio pulses. Comets can produce radio waves when solar wind interacts with their coma, generating electrical discharges or magnetic field variations. It is plausible that a comet releases ionizing gases producing emissions at specific frequencies, though the pattern would be chaotic, not a mathematical code. Moreover, the hydrogen frequency is not exclusive to artificial signals. Hydrogen in a comet's coma can emit at this wavelength, again diffusely. Thus, an erroneous detection or coincidental noise might create a pattern illusion. On the other hand, 8, 13, 8, 5, 13, 8 is not the full Fibonacci sequence, a subset. It could reflect the comet's rotation period and jet effects. Random coincidence is also possible. Humans excel at finding patterns where none exist. This cognitive bias, apophenia, is the tendency to perceive meaningful connections in random data. Constellations exemplify it. We project figures onto the sky seeking coherence. In radio astronomy, fluctuations have appeared encoded at first glance but dissolve into noise under rigorous analysis. This reminds us that an isolated detection must be replicated and verified before conclusions. As these matters are debated, I cannot help reflecting on what drives our signal fascination. Perhaps our species is programmed to seek meaning in the universe. From ancient times, we gazed skyward for God signs or other lives. Augurs interpreted bird flights. Astrologers saw destinies in stars. With science's advent, we transformed this quest into searching physical laws and extraterrestrial intelligence. The Fibonacci sequence, with its apparent ubiquity, has become a modern myth, a secret code nature inscribes everywhere. The hydrogen channel symbolizes our hope for universal communication. When signal news emerges, imagination soars. For many, the notion of something or someone across the immensity sending us a message resonates with a profound desire not to be alone. Thus, though the Fibonacci signal story dissipated under scrutiny, its narrative power endured. It compelled us to ask what we would do if a real message arrived. Respond? Stay silent? What say? Beyond signal authenticity, the generated conversation mentally prepared us for a future perhaps holding real confirmation. Returning to 3I Atlas, its passage will continue generating data and debates. Perihelion occurred late October, when the comet approached about 130 million miles from the Sun's solar radiation was then intense, cometary activity maximal. It will then recede slowly, reaching closest Earth approach in December at about 170 million miles, then Jupiter in March next year. Space and ground telescopes will seize every observation opportunity. The European Jupiter Icy Moons Explorer mission, specializing in Jupiter and its moons, will conduct measurements in November passing relatively near the comet. Data may reveal surface temperature, density, and jet distribution. The Juno orbiter will also provide infrared observations potentially exposing internal cavities or peculiar structures. Meanwhile, spectroscopists will continue analyzing chemochemistry to confirm metallic compounds and possible origins. Each measurement brings us closer to understanding whether anomalies are natural whims or conceal something deeper. In any case, 3I Atlas has left its mark. It reignited discussions on technosignatures, signals or artifacts indicating advanced civilization, and motivated the community to scrutinize interstellar visitors more closely. Personally, this episode taught several lessons. First, our capacity for wonder is healthy but must accompany critical thinking. Hearing a comet emitted a Fibonacci signal, I do not mock believers, knowing science advances through bold questions. Yet I accept nothing without evidence, as blind faith undermines the scientific method. Second, scientific communication is crucial. When agencies like the National Aeronautics and Space Administration silence for administrative or precautionary reasons, the information vacuum fills with speculation. We scientists must learn to better convey what we know and do not, lest imagination run unchecked without anchor. Third, searching intelligent life signals is a path of patience. Distinguishing real signal from noise demands time, repetition, and global collaboration. Though most anomalies prove natural, each investigation advances cosmic understanding. Ultimately, fascination with a possible Fibonacci message reflects our drive to connect and find order in the universe. But the true message received here came not from the comet, but nature itself, a reminder that the cosmos is vast, complex, and astonishing, with our comprehension still partial. I wish to conclude with an invitation to reflection. 3I Atlas proceeds indifferently to our doubts and hopes. It may be a mere exotic comet, relic from a distant system, or something more. Yet its story showed how science and imagination intertwine. It reminded us to keep minds open without forsaking rigor. And it gave reason to view the sky anew. Ultimately, every interstellar visitor is a letter the universe sends us. Our responsibility is to read it carefully, learn from it, and above all keep curiosity alive. If this narrative intrigued you, if you feel the pursuit of truth and cosmic exploration deserve sharing, join our channel, like, and subscribe so we continue unveiling the universe's secrets together. For though this time the Fibonacci sequence proved illusory, we know somewhere in space a real message may await decoding. To be ready, we must keep observing, preparing, and understanding.